morning all. Am I audible? Do let me know in the comment section. Is it fine? I don't know how many of you there in the live. Do let me know. Shall we start the session? Yes. Good morning, Manivannan. Fine. I hope I am audible. Let us start the session. So in the last class, we saw the fundamental basics of electrical circuits, like fundamental basics of three-phase basically. And we saw what are all the classifications and how to solve them. Everything we saw, like how to calculate the three-phase power for the source, for the load. Everything has been classified already. Now it is a time to start solving the problems. So let me drop the first question here. As usual, keep clock with you all. Take your own time. Try to bring the answer. If you are not getting the answer, then I will try to solve it. Okay. Now, there is a question. The question given it is the line A to neutral voltage. The question is the line A to neutral. They have given a voltage. The line A to neutral voltage is given as 10 at an angle of 15 degree. This is voltage, volt, for a balanced three-phase star connected load. For a balanced three-phase star connected load. For a balanced three-phase star connected load. Three-phase star connected load. First thing. And it's having the sequence star connected load. You can write like this with the sequence of ABC. They told that it is having a certain sequence, that is ABC. The voltage of the line B with respect to line C is given by, the question is the voltage of line B, the voltage of line B with respect to line C is dash. They have given some options here. Option A, 10 into root 3 at an angle of 15 degree. Option B, 10 at an angle of 105 degree. Option C, 10 into square root of 3 at an angle of minus 75 degree. Option D, minus 10 into square root of 3 at an angle of 90 degree. So they had given four options. Now you can take maximum 2 to 3 minutes to solve this question. Try to solve and drop your answer in the comment section. Okay, do it fast. Do it fast. Don't waste your time. What can be your answer? Anyone got the answer? If you got the answer, do let me know in the comment section. Either it is option A or option B or option C. Anyone? Nobody got the answer. Your time is over. I am giving one more minute. Try your best. Option C, Sugumari. Good. 10 into root 3 at an angle of minus 75 degree. Very good. Any other answer? Any other answer? Take your time. This is three-phase circuit, but it is also very important to learn these things in a proper way. Use normal calculations. Chalo, your time is over. Let me try to solve this question. Okay. Keep smile in your face. Don't be dull. Let us start. Basically, what they told, let us read the question once. The line A to neutral. So I'm just asking you, line A to neutral means, so they are measuring the voltage between a line and neutral means a line which is strictly connected with the ground. So when you are trying to measure the voltage between line to neutral, that voltage is simply called what? Phase voltage, you all know. I told you, instead of that, if you are measuring the voltage between two phases, that is two lines, then that voltage is simply called line voltage. That is the difference between line voltage and the phase voltage. Now, while reading the question, I clearly understood that The given voltage is line to neutral means they are talking about phase A voltage. Yes or no? First conclusion. Line to A can also be C. I am naming it as phase A. Now it is connected with the neutral, so I am putting VAN. EAN. We can also write like this: VAN equal to 10 at an angle of 15 degree. Okay. Now in the question next, if you continue further, for a balanced three-phase star connected. See, when the moment they told that they are measuring the voltage between line and neutral, neutral line will exist only in star connection. We saw there are two type of connection. One is a delta, another one is star. The external line, the neutral line, one more line will exist only in case of star connection. In delta connection, only three lines are possible, whereas in star connection, you can go up with the three or four. Three lines means without neutral. With the neutral means you will be having four lines. Fine, sir. So phase voltage is given. Now the question is, they had given the voltage between phase A to neutral in star connection. They are talking about B and C. So let us draw it. Let me go ahead here. First, let us draw the star connected system. This is star connected system. This star connected system, now it is also having one more line, that is neutral line. So let us connect like this. So this is neutral line. Now what they have done is they have started measuring the voltage between phase A to neutral, and they told that the voltage between A to neutral is 10 at an angle of 15 degree. Then see, this is phase A. From here after 120 degree I must keep phase B. So where is your phase B? This line is going to be your phase B. It is very important. You cannot simply name ABC. First A, after 120 degree, which line is appearing here? So that line will be called phase B. So from here after 120 degree, which line is appearing? This line is appearing. This line is called phase C. Now they are measuring the voltage between B to C. If you observe the question carefully, star connected balanced load. Star connected load with the sequence of A, B, C. First they told the sequence of A, B, C means I should start from A, then I have to reach B, then I have to reach C. So A, B, C is the given sequence. Next thing is the voltage of line B with respect to line C. So the voltage of line B only they are talking. So we have to start from B, it will be ended up C. So I can write VBC. The voltage of VBC is dash. That is the given question. I hope you all have understood. So let us write like this. Now I am only talking about phase voltages. Later we will be dealing with the line voltages. We know how to bring the relation between line and phase voltages. I hope you all have remembered this basics. Fine, sir. Now, when the moment we are talking about phase voltage here, given it is the value of VAN equal to 10 at an angle of 15 degree. Fine, sir. Now, I'm just asking you, can you write down the expression for VBN? Can you write down the expression for VCN? Is it possible? If it is possible, please do it. I can write the expression for VBN. How do I write the expression for VBN? VBN can be strictly written as when the moment we are going from A to B, B will be 120 degree lagging from A. C will be 120 degree lagging from B. Yes or no? Yes, sir. So I can write like this. Voltage of the phases will be remain same, but the phase angle. Already it is having 15 degree. With this minus 120 degree will be added such that VBN will exist. So if you elaborate this, minus 120 plus 15 degree will give you minus 105 degree. Yes, sir. Now from here again I should reach phase C. How will you write? I told you there are two ways. Directly you can write the phase C. See, phase C is 120 degree leading from phase A, or you can also say 240 degree lagging from phase A. Yes, sir, that is correct. There are many ways to write. So I'm directly taking phase A voltage. With this, I'm adding 120 degree leading, such that you can obtain phase C, that is leading degree. So it will be 15 plus 120 will become 135 degree. So we have obtained the value of VAN, VBN, VCN. Of course, VAN is given. From this, I have tried to, yes, we brought the value of VBN and VCN. Okay, sir. What is the purpose? See, basically, they are talking about line voltages, right? I'm just asking you, how will you write the expression for line voltage from phase voltage? I'm having phase voltage, I need line voltage. It's very simple. See, we are trying to measure the potential difference between C and B. Sorry, B and C. So that can be written as integerally VBN minus VCN. That is called VBC. VBN minus VCN will give you VBC. Simply we can say potential difference between these two phase voltages will give you the value of line voltage. That's all. Okay, sir. Now that is, see, I'm not telling you something new. Basically, how will you calculate the voltage? See, we are finding the potential difference between these two terminal only, and we are going from B to C. It was given in the question. Line B with respect to C. So I'm going from B to C. That's all. So simply VBN means the potential voltage that is available at the terminal B and the voltage that is available at the terminal C. Find the potential difference between them, that will give you the value of VBC. That's all, it is over. Now what is the value of VBN? VBN is given as 10 at an angle of minus 105 degree minus VCN is given 10 at an angle of 135 degree. It's over. Now from this you can take the value of 10 outside. This can be, again, see, directly I cannot add two polar values. I have to convert it into rectangular form. Then at last we will see the resultant answer. So this can be written as e power minus j 105. I am converting into rectangular form, e power plus j 135 degree. So this can be further written as 10 into cos of 105 degree minus j times of sine of 105 degree minus of, here e power j 135 can be written as, once again I'm keeping minus outside, cos 135 plus j sine 135. Why I am putting plus here? Because in the power of e I'm having plus. So this is over, overall bracket also over. Now take your calci, estimate the value of cos 105. Let me also do it. You can also do it by yourself. Do it by yourself, that will be good. So 105, if I take cos, so I am getting 10 minus 0.2588 minus j 105. If we take sine, I am getting 0.9659. Now I am passing this minus inside the bracket, minus, once again, 135. If we take cos, that will give you one minus, so minus into minus will become plus. Now see, this minus is common for both cos and sine, okay, but cos 135 is giving us minus 0.707, so minus into minus will become plus 0.707. Then minus j, if we take 135 sine, it is also giving same 0.707 but plus. Okay, sir. Now let us club both real and imaginary part. See, this is one imaginary part. If you observe, we are having two real parts. First, 0.707 minus 0.2588. So 0.707 minus 0.707 minus 0.2588. If we will put that, we will be getting 0.4482. Then minus, see, we can add these two, both are in minus, so minus j, once again, 0.707 plus 0.9659. So if we add these two, we will be coming up with the 1.6729. So now it is in completely rectangular form. What you can do is you can multiply it by 10 if you want, so it will become 4.482 minus j 16.729 voltage. So it is in rectangular format. But if you observe your option were given in polar format. What you have to do? You know how to convert it into polar. So let us do it. Find out the magnitude. First 4.482, 16.729. So 16.729 plus 4.482. We have to square it, don't forget. So I'm getting 17.31. So the magnitude of VBC will be 17.319, approximately 17.32. At an angle of phase angle, we must find 1 minute, 16.729 divided by 4.482. You know how to calculate the phase angle, right? First, we have to take tan inverse. So tan inverse of imaginary by real. You will get phase angle theta. So I am getting minus 75 degree volts. So this is the correct answer for the given question. Okay, how will you calculate the phase angle first of all? To calculate the magnitude, you know, square root of real part 4.482 whole square plus imaginary part minus 16.729 whole power 2. This is magnitude. Phase angle theta equal to tan inverse of imaginary by real. You can take that minus outside. See, imaginary is having minus 16.729 upon 4.482. You can take this minus outside, you can keep it here, nothing will be wrong, and you can now you can find out the answer. Both will give you the same answer. Whether it doesn't matter whether you are keeping that minus inside the bracket or outside of tan inverse, both will be giving you same result. Okay, both are same only. So that is how we are finding the magnitude and the phase angle. So finally we got the value of VBC. Now from this question, what you have understand? Basically we are they requested us to estimate the value of VBC, right? So basically, but what it was given, simply they told only the value of phase here. But what I have done, I brought the relation between A, B, C. Now, whether will you be able to find out all other voltages or not? Now you know how to calculate the VBC, right? Now you can try to calculating the value of, sorry, 1 minute. Yes. So now you can try calculating the value of VAB also. Then you can also try to calculate the value of VCA or CA also. How will you calculate the value of VAB? VAB means it is VAN minus VBN. How will you calculate the value of VCA? It will be VCN minus VAN. Because you know how to bring the relation between line and the phase voltages. So it is normal circuit theory, how to simply find the potential difference between two phases to obtain the line voltage. That's all. That's very simple now. I hope you all have understand the logic behind of this. Okay, sir. Now let us go ahead with the next question. This is the given question. I am reading the question first. The question is, using Thevenin equivalent circuit, determine the RMS value of the voltage across the 100 ohm resistor. Question is what? Using Thevenin equivalent, you can use the concept of Thevenin. Using Thevenin equivalent. Using Thevenin equivalent, the question is, determine the RMS value of the voltage across the 10 ohm resistor. RMS voltage, VRMS across the 10 ohm resistor. RMS voltage across the, sorry, that is not 10 ohm, 100 ohm resistor. That's all, using the Thevenin equivalent. That is the given circuit. You can see the supply is having 400 voltage balanced. Remember one thing, always in case of three-phase circuit, you will be dealing with the line to line RMS voltage only. By standard default, they will give you only line to line voltage, and that too is what? RMS voltage. Okay, don't forget this. That is very important. Suppose if they are giving phase voltage, then that will be mentioned. Okay, that will be mentioned in the question itself. If in the question itself given voltage is force phase voltage, then you can take. Otherwise, if they haven't talked about the given voltage, then consider the given voltage is RMS voltage only, line to line RMS voltage. Okay, you may proceed now. Bring the answer. இந்த phase balanced ன்னு கொடுத்திருக்காங்க இல்லையா, அதை ரீட் பண்ணி அதை phase voltage ன்னு எடுத்துக்காதீங்க. They told that 400 voltage phase balanced in the sense the sequence RYB given RYB is balanced one. System is balanced. eh, Both load and source sides. Take your time. I'm giving you once again 2 to 3 minutes. It is 5:29. You must be submit the answer before 5:32. Last question answer. Dinesh Ravichandran A. Kanaga Savita A. Actually, what is the option? Last question is the correct answer option. A. No, it is not A now. So 10 into root 3. This can be written as 10 into 1.732. Of course, it is 17.32. At an angle of, we got minus 75. Option C. Sure. Proceed with this. Bring out the answer. Got the answer? Spend your time. Just little bit think. Kanaga Savita, 115.5 voltage. Very good. Any other answer? Any other? Drop every one of your answer in the comment section. It doesn't matter whether you are getting 1000 or it is higher than the given, whatever it is. But solution must come from your own mind. It should be okay. Don't think like that. Anyway, he is going to solve. Instead of thinking like that, try to bring the answer by yourself and keep smile in your face. It's early morning, so you can keep what I can say, fresh mindset and a happy mode, pleasantful, peace mind. You can try to bring the answer as fast as possible. If you are not having any idea, just wait. And but you might have some idea about three-phase circuits. Yesterday also we have revised. So just try to apply all the basics, whatever that you have learned. You may get the answer. So no one got the answer. Sure, your time is over. Let me try to solve the question by myself. Okay, let us see. Now here, basically we are having three phases RYB. It is connected with the star connection. If you observe, both are in star connection. Nothing is there. Just to go with the normal Thevenin analysis. You don't need to do any blah blah circuits. It is clearly told that using Thevenin equivalent circuit, find out the voltage drop across this 100 ohm resistor. Initially, the switch is open. See, if you observe this, the switch is initially open. Anyway, even while calculating the Thevenin circuit also, they told that this 100 ohm resistor is acting as a load. First thing. Tell me what is the procedure to calculate the value of Thevenin voltage, first of all. They told that we should use Thevenin equivalent circuit. How will you draw the Thevenin equivalent circuit? If it is an AC circuit, if it is an AC circuit, then it can be written as Thevenin voltage connected in series with the Thevenin impedance, ZTH. We are in AC. At last, we can reconnect the load to the circuit, that is called load impedance. So I'm calling it as load impedance. So we have to draw like this. After that, you can find out the voltage drop across this load impedance and load voltage, but it should be RMS. Okay, that too fine. This is the question. So it is very important to identify the value of Thevenin voltage and Thevenin impedance before starts analyzing the circuit. How will you calculate? Let us see. So the question number one. What is the procedure to estimate the value of Thevenin voltage? Step number one. Identify the load impedance. Yes, sir. Here the value of load impedance is 100 ohm. We have identified the load impedance. Step number two. Strictly remove the load from the load point. We have to remove this ZL load impedance. Okay, sir. Step number three, to estimate the value of VTH, simply calculate the voltage, that is called the Thevenin voltage, or we can also call it as open circuit voltage across what? Across load terminals. Across load terminals. Load is removed from there, but I am trying to measure the voltage from its terminal. Got it? So we know this procedure. So I'm just going with that procedure. Let me remove the load and I'm redrawing the circuit for your understanding. So what it was given. So they told that this animation is good, right? எல்லாரும் இப்படி தான் தூங்கிட்டு இருக்கீங்களோ? So let me try to solve this one. See what happened here. We kept 300 ohm resistor. Yes, sir. And the terminals, 1 minute. Yes. 300 ohm resistor, it's fine. Now we should connect phase B with the phase B, phase C with the phase C. It is very important. Yes, so phase C is already connected. See, if you observe, these two terminals are called Thevenin terminals. Where is the load? See, the load is strictly connected between these two terminals. These two terminals. Here only we have connected the load. Yes or no? So this is the load point. Anyway, now it is detached. I have removed this load because we are measuring the value of Thevenin voltage. So between these two terminals only we are going to measure the voltage. That voltage is simply called Thevenin voltage. Okay, sir. I'm understanding this, right? Now if you observe the phases terminals, they kept the name R, Y, B. Three terminals. See, already they have given the name for the source. I am taking the same name for the load. Nothing will be wrong here. Fine, sir. Now, what they told, the RMS voltage, line to line voltage only they told. I'm repeating, by default, the given voltage is always line to line RMS voltage only. And the given connection is star connection. And system is balanced at 2, right? Fine, sir. Now, if the line voltage, if the line to line RMS voltage, I am just considering the magnitude. Or you can write like this, line to line voltage. That too, I am writing for first. Phase A is R, Y, B. If I am taking R as the reference, so line to line voltage for the first R to Y, what will you obtain? See, basically we will be writing like this VRY, then VYB, then YBBR, three voltages. So it will be written like this. I am writing the first one. I need first phase only because here we are going to measure the voltage between R to N. It is Y, it is B. So here I need the phase voltage of Rn. Okay, sir. How do I calculate that? For that, I am just calculating the Ry first. That is line voltage. That is given. I no need to measure. That is, but it can be written like this: 400 at an angle of 0 degree. Say they had given only magnitude, so I am assuming it is starting at a 0 degree only. If it is not given, then you can take it that it is. You can assume that it is starting at a 0 degree. Okay. If the line voltage is 400 at an angle of 0 degree, then how do I write the magnitude of the phase voltage? Directly. You know how to write? It's very simple. You know, phase voltage can be written as line voltage upon square root of 3. So line voltage is given as 400 at an angle of 0 divided by 3. Okay, sir. This is over now. I'm just considering magnitude. I'm repeating again. I don't want the phase angles here. Okay. Fine, sir. We brought this because in the question, given it is just we have to find out the magnitude of the voltage. Okay, sir. So phase voltage will be line voltage divided by root 3. I am considering only magnitude, that too. Okay, sir. We found the phase voltage. Now, what is this? This is line to line R2 Y voltage. Then this voltage can be written as Rn. Yes or no? That is phase voltage. So that is the phase voltage. I can say that is the voltage drop across the R to N. System is balanced. So directly you can take the line voltage of this R to Y as the line voltage between these 300 ohm loads. Both are star connected loads and sources. Source also star connected, load also star connected, and both are balanced. So whatever the voltage that is there in the star connection of the source, that values will be appearing across the load. So I can say the per phase voltage drop across the 300 ohm resistor, and I am talking about R to N, will be equal to 400 upon square root of 3 voltage. We found the voltage drop across it. Now tell me, what is the value of Thevenin voltage? Thevenin voltage is nothing but the voltage drop across the 300 ohm resistor only. So directly I will be treating it as Thevenin voltage, or I can call it as open circuit voltage. See how simple your question it is. Simply just you have to bring the phase voltage from the line voltage. Am I telling anything new here? Nothing. Just whatever they are giving in the question, and just with the data I am doing this analysis. That's all. Okay, sir. Phase voltage is over. Thevenin is over up to this. Now, how do I calculate the Thevenin impedance? What is the procedure? Once again, identify the load terminal. Step number 1. Step number 2, remove the load from the load terminal. Step number 3, deactivate all independent sources. In your circuit, if you observe, there are 3 independent sources: 400 voltage source, 400 voltage source, 400 voltage source. If I will deactivate all these sources, how this resultant circuit will be looking like this? See, I am shorting all the voltages. So let me redraw the circuit again for your understanding. After short circuiting the circuit, this is how our circuit will be looking like. Then what can we do? So we know, this line will be connected with this one. This is RYB. Sequence is very important. So it is connected here. This is how our line is looking like this. Anyway, from here only we are going to calculate the value of Thevenin impedance. Now, observe the circuit. This is 300. Carefully observe the circuit. Can you please help me to identify the value of Thevenin impedance? Voltage source வந்து நான் short circuit பண்ணிட்டேன். Now it is your responsibility to calculate the Thevenin impedance. How do I do that? If you observe the network carefully, see there, I am just asking you, after short circuiting all the voltages, what is the difference between these two nodes? Do you have any load between this node and this node? See there. Do I have any node, any loads or any elements between these two nodes? No, sir. When there will be no any elements in between two nodes, if it is simply short circuited, then I can directly consider these and these nodes are same only. You can treat like that. So I'm going to simply attach this node with this node. If I will attach like that, then how our circuit will be looking like? See, let us see. If I will extend this line directly, if I am connecting it here, and I am going to connect this line directly here. I said all are same only. In that case, how your circuit will be looking like this? The resultant circuit will be looking like, see, I am having one load here. Yes, sir. I am having one more load here. Yes, sir. I'm having one more line here. Yes, sir. See, now I'm going to directly connect this line with this. I'm directly connecting this line with this, and we are measuring the Thevenin impedance from here. Yes or no? Just observe the circuit. I'm not doing anything new. That's what I told you. This line is simply going to be connected here. That's what I'm doing. After doing that, now at least recognize the circuit. See there, if I'm naming this node, there are two nodes. Let me name the nodes for your understanding. See, this is one node and this is one node. Let us take node A, node B. Or we know this node is Rn only. Let us go ahead with the same Rn. Between R and N, if you observe, first I have a 300 ohm resistor. Again between same R and N, I am having one more 300 ohm resistor. Again between same R and N, I am having one more 300 resistor. What is the difference between this circuit and that circuit? See, I am drawing one more circuit. I am just asking the difference between this one. This is new one and older one is already present in the right side. Sorry, in the left side. Now see there, this is R, this is N. Tell me what is the difference between first circuit and the second circuit. This is first one, this is second one. Whether both are same or not. Between same R and N, we have three 300 ohm resistor. All are connected in parallel. Now how will you calculate the value of Thevenin impedance? Sir, it is very simple. I told you, when the parallel branches are having identical resistors, that is same value, what we have to do? Select the common resistor value divided by the number of parallel branches which are having identical values. So it will be equal to 100 ohm. You know how to calculate the Thevenin impedance in this case. Do you remember? Let me repeat one more time. When more than one parallel circuit are having same value of identical, that is same value of resistor, what we have to do? Select that common resistor value. Here, the parallel circuit having the common resistor value of 300 in all its parallel lines. Take that resistor value divided by number of parallel branches are having the same resistor. Three branches are having same resistor, so common value of the resistor divided by number of branches will give you the resistant value. Finally, we found the value of Thevenin impedance, Thevenin voltage. Let me draw the circuit at last happily. So we found the voltage, I think that is 400 by root 3. It is here, 400 by root 3. So let us substitute that value. It is attached with the Thevenin impedance. Then we are going to connect load with this. Yes, sir. So now what we can do is, this is called Thevenin voltage. Yes, this is called Thevenin impedance. This is the load impedance. We are going to measure the voltage across the load impedance. Yes or no? RMS load voltage. Let us see. Thevenin impedance is 100 ohm. Yes, sir. Load impedance also 100 ohm. It is given in your question. Do you remember? Go back. See, load impedance is 100 ohm. They told already. Thevenin voltage. Thevenin voltage is 400 by root 3. 400 upon square root of 3. Yes, this is Thevenin voltage. Okay, sir. Now tell me, simply apply voltage division rule. Find the voltage drop across the load impedance. Total voltage offered by the supply is 4 root 3 into voltage drop across the load impedance. Load impedance divided by total impedance offered by the network. Load impedance plus Thevenin impedance. So what will you obtain? It will be 400 upon square root of 3 into, it is 100 upon 100 plus 100 will be 200. So it will be 1 by 2. 1 by 2, if we cancel it, finally you will be coming up with the 200 upon square root of 3 is your correct answer. Now tell me what is the value of 200 upon root 3. If we take, I am getting 115.47 exact voltage is going to be. So the exact load voltage, load RMS voltage is equal to 115.47 voltage. Got it? So that is how we are calculating the voltage. Anything you can calculate now. See, in the same way, you can do anything that you want in this given circuit. This is load impedance that they have asked you. Yes, sir. No, suppose if I am asking you what is the current flow through the phase A and what is the current absorbed by the phase B, what is the current absorbed by the phase C, how will you calculate? Strictly, they have given the line voltage now. How will you write down? See, let me analyze everything. Anyway, I have dropped the answer for your question. It's over from my end. Apart from that, what are the things that we can do? Yes. Sir, given it is line voltage. So line voltage can be written as VRY equal to 400 at an angle of 0 degree. Yes, sir. Then directly VRY from this RYB is the sequence. So remember this. Sequence is very important. RYB. So first I am writing the line voltage between R to Y. Next we must write Y to B. So this can be written as Y to B. What is the phase angle difference? So from R voltage is having 0 degree, but whereas when I am considering Y, first one is main voltage, R to Y, Y to B. Y to B will be having minus 120 degree lagging. Similarly, if you go, this is VRY, VYB, next BR, right? So 1 minute, I made a mistake. Write the expression for B to R once again. So this can be written as 400 voltage at an angle of plus 120 degree. So this is how we are writing the line voltages from the given data. Okay, sir, this is fine. How will you write down the phase voltage for this? Similarly, for the same circuit, I would like to write down the phase voltages. So now, since the given circuit is star connected network, given circuit is star connection. As I told you, for our question, I haven't considered the phase angle. Yes or no? I haven't considered the phase angle. But when line voltage is given, you know how to bring the phase voltage. How will you bring? Let me tell you. First of all, the relation between phase voltage and the line voltage is in case of star connection. Phase voltage will be having line voltage upon root 3. This is the first one. This is, I am talking about only magnitude. Let us discuss about the phase angle difference. Do you remember? Yesterday, I have raised one small question for you all. Do you remember? Anyone, can you drop your answer in the comment section? I told you, I have just asked you, what is the phase angle difference between phase voltage and the line voltage in case of star connection? Anyone got the answer for that? Just to drop your answer in the comment section. So of course, definitely it will be what? The phase difference between line voltage and phase voltage will be 30 degree. Yes or no? I told you. But whether it is leading or lagging. So I'm having a doubt. You please tell me. We are having line voltage and phase voltage, right? What is the exact phase angle difference between line voltage and phase voltage? If you observe, let me tell you. Voltage division is applied to phase voltage. The answer is Rajesh. You are asking that voltage division is applied for phase voltage, sir. Answer is line voltage, line RMS voltage. Line RMS, sorry, using Thevenin equivalent, just VRMS, voltage drop across the 100 ohm resistor is dashed, right? See, first of all, observe. Questionல என்ன எந்த இடத்துல load connect ஆயிருக்கு பாருங்க. Rajesh, you just observe this. See, என்ன கொடுத்திருக்காங்க இங்க 300 ohm load கொடுத்திருக்காங்களா? அதுக்கு ரெண்டு டெர்மினல் இருக்கு. One terminal is connected with the neutral, another one terminal is connected with the line. இவங்க ரெண்டு பேருக்கு நடுவுல தான் வந்து load கனெக்ட் பண்ணிருக்காங்க. Am I right? அப்ப நம்ம வோல்டேஜ் வந்து இந்த ரெண்டு டெர்மினலுக்கு நடுவுல மெஷர் பண்ணோம் அப்படின்னா இங்க லைன் வோல்டேஜ் கிடைக்குமா இல்ல ஃபேஸ் வோல்டேஜ் கிடைக்குமா? Basically we are measuring the voltage between line and phase. It should be a phase voltage. Am I right? Voltage division, yeah, that's why load is already connected between two phases. Sorry, one phase, one neutral. Load is already connected between phase and neutral only. It should not be a line voltage. It should be a phase voltage. Rajesh, got it? Okay, fine. Chalo, let us continue. Yes, we know Kanaga Savita, good. So basically, in case of star connection, do remember this. Always, if you observe, line voltage will be 30° leading from the phase voltage. 30° leading. So how I can write like this is, so we can write like this: line voltage equal to phase voltage, right? Directly magnitude will not be the same. Remember one thing, line voltage equal to root 3 times of phase voltage, right? So it should be multiplied by a factor of root 3 at an angle of plus 30°. This is how we are writing the expression for line voltage. If you are writing the expression for phase voltage can be written as line voltage upon square root of 3 at an angle of minus 30°. So this is how we are writing the expression for phase voltage from line voltage. And this is how we are writing the expression for line voltage from phase voltage. Do remember this relation, both are very important. Anyway, we are in phase voltage now. I need phase voltage. So line voltages are given. Now let me write the expression for phase voltages. Phase voltages means VRN, VYN, VBN. See, just clear all your doubts here itself, in circuit theory itself, okay? Such that it will be very easy in power system, machines, power electronics. VRN, how will you write the expression for phase 1 now? See, we know phase A, line voltage of phase A, already we know R2Y, this is 400. If I will divide it by root 3, then I will get the phase voltage. See, just now I write the relation. Line voltage divided by root 3 at an angle of, already it is having 0°. So with that we are adding one more minus 30°. It is very important to consider this value. It is 400 at an angle of 0. With that we are adding minus 30. So this can be written as 400 upon square root of 3 at an angle of minus 30°. That is the value of positive phase voltage. Let us focus with the second phase voltage. The second phase line voltage is what? 400 at an angle of minus 120. Already it is having 400 at an angle of minus 120. I have to divide it by root 3. With this we are also adding one more minus 30°. Why? Because phase voltage is lagging 30°. So if I will rewrite this expression, this can be written as 400 at an angle of root 3. Sorry, 400 upon root 3 at an angle of minus 150°. Similarly, can you write the expression for VBN? Yes, sir. It can be written as 400 at an angle of plus 120° or minus 240. Both are same upon root 3, but it should be added with the one more minus 30°. You know the reason now. So this can be written as 400 at an angle of root 3. Strictly from this, 120 minus 30 will give you 90°. Now I found the phase voltages of three phases. Now if you observe, there are three phases. Phase A is having 300 ohm, this is having 300, this is also having 300, and we found the voltage drop across the phases. See, since the system is star connected, load also star connected, so the line voltages and the phase voltages of the load and the sources will become same because both are star connected. Whatever the voltage that you are measuring here, same voltage will be appearing here and balanced. One more thing is they are balanced, strictly balanced. Fine, sir. So this is the actual way of writing the expressions for balanced system. Okay, sir. Now I found the phase voltages. Can you write the phase current? Why not? How will you write the phase current? Generally, according to Ohm's law, phase current can be written as phase voltage divided by phase impedance. Yes. Now, if we observe our system, it is given as our system is having, let me clear it first. Yes. So our system is having a load of how much? 300 ohm. Okay, it is not resistive load. They simply told magnitude only because I too don't know what was there. So let me give it a rectangular box. They told it is 300 ohm. I too don't know. But they told there are three phases and they are balanced. All are having same 300 ohm. Yes, sir. Now we found the voltage drop across the all phases. We know the voltage for R2 neutral. We know the voltage for B2 neutral. We know the voltage for C2 neutral. When you know this, now I would like to know the current flow through the first phase, first load. That can be written as IRN, phase voltage of phase current through the first 300 ohm resistor. So phase current equal to phase voltage VRN divided by phase impedance ZRN. Do you know all the values? Yes, sir. Let us see. VRN is how much? 400 by root 3 at an angle of minus 30. So this can be written as 400 upon root 3 at an angle of minus 30 divided by what is the impedance? It is 300. So this can be further written as 4 by 3 into root 3. Am I right? This 0 will be cancelled out at an angle of minus 30 ampere. This is the current flow through the first phase. Similarly, if you write down the expression for second phase, IRN is over. Next, let us focus on B. So this can be written as IBN. This can be written as VBN upon ZBN. How will you write it further? So same expression, sir, 400 upon root 3. You know the value of VBN already we have estimated. 400 by root 3 at an angle of minus 150. Minus 150. Yes, sir. So this is the voltage divided by impedance value as usual 300 ohm. If you reduce this, once again it will be coming up with 4 by 3 into root 3 at an angle of minus 150 degree. Yes, sir, 150 degree ampere. Fine. Chalo. If you write the expression for ICN, this can be written as phase voltage VCN upon once again ZCN. From this, how will you write down the expression? The expression can be further once again written as 1 minute. Yes, sir. So phase voltage, what is the phase C? 400 by root 3 at an angle of 90. So it will be 4 by 3 into root 3 at an angle of 90 degree. I am writing it directly because now you know how to write the expression. So we found the answer for all these cases. Yes, sir. So IRN is over, IBN is over, ICN is over. Now, may I know the value of IRN plus IBN plus ICN? Anyone? Tell me what is the addition of all this quantity. Let us see. So yes, values. So first one is, let me do somewhere here. So the first value is 4 by 3 into root 3. See, it will be minus 30 degree plus the second phase is having 4 by 3 into root 3 at an angle of minus 150. Third one is having 4 by 3 into root 3 at an angle of 90 degree. Let us convert it into polar. See, 4 by 3 into root 3 is common for all. So I am taking it out. First term, this can be written as e power j 30 or I am writing it directly. Cos 30 minus j sin 30. Yes. Second expression, minus 150 degree. It can be written as cos 150 minus j sin 150. I am converting into rectangular form. Don't confuse. Next, 90 degree. This can be written as cos 90 plus j sin 90. Yes. Let us reduce all these values finally. What we are going to obtain 4 by 3 into root 3. Let us sum up. What is the value of cos 30? I hope it will be root 3 by 2. Minus j sin 30 will be 1 by 2. Yes or no? Yes, sir. Plus, what is the value of cos 150? May I know the value of cos 150? That is also root 3 by 2 only. But that is minus root 3 by 2. Minus root 3 by 2 plus, sorry, minus j sin 150. If we take it will be 1 by 2. Sin 150 will be 1 by 2. Then again cos 90, it will be 0. We all know it will be 0. Plus j sin 90 will be 1. So let us add all these values. See there, root 3 by 2, root 3 by 2 getting cancelled, because here I am having plus root 3 by 2, it is minus root 3 by 2. Then minus j into 1 by 2 minus j into 1 by 2 will be giving minus j. Already we having plus j, we are having minus j plus j will be equal to what? It will be 0, sir. Finally, what we have understand here? What you have understand here? I just need the conclusion. I just wanted to know the conclusion. Sir, I have done so many things here. Yes, sir. But finally what I got, the resultant value will become 0 ampere. Addition of 3-phase current will be 0. Why it is? Why it is? Why? Because I told you, when your system is balanced one, when your system is balanced, then all the values are equal. IRN, IBN, ICN all are having same value with except phase angle difference. So when your system is strictly balanced, then addition of 3-phase current. Do you remember IRN? In the basic lecture, I taught you yesterday, IYN, ICN will become equal to 0. That is called balanced system. So in case of balanced system, additional wire, that is that I am telling now, in case of star connection, basically we will be having one more line, that is called a neutral line. This neutral line is not required when your system is balanced, because in a balanced system, addition of 3-phase currents are resultant equal to 0. So why we need to carry 0 ampere by using one more line? It is 0 already. So when your system is unbalanced, only in that case, neutral line will be existing with the star connection. I hope now you got the clear conclusion about the circuits. So let us go ahead with the next question. So this is the given question, and the question is a set of 3 equal resistor, each value of Rx connected in star connection across the C. Guys, listen, let me write down the data. A set of 3 resistor Rx, all are having same value. External resistors, Rx means simply 3 external resistors connected in star. They are making connected in star across RYB in RYB of given figure. Okay, just compare the given data with the given figure. Now the question is, consumes the same power at the unbalanced delta connected loads shown. They are consuming the same power as the unbalanced delta connected shown, as the unbalanced, mark down the word unbalanced delta connection shown. Unbalanced delta connection shown. Now the question is, then what is the value of Rx? Figure out the value of Rx. That is the given question. You can take 3 to 4 minutes for this question. Try to solve it. Question first NS clear observe. This is the given diagram and it is connected with the 3 terminals R, Y, B. Next, what they told, a set of 3 external resistor, name is REX. See, this is EX. External resistor connected in star across RYB. இதுக்கு வெளியில கனெக்ட் பண்றாங்க போல of a given figure. அவ்வளவுதான். ரிமைனிங் டேட்டாவை நீங்களே ரீட் பண்ணுங்க, because I don't want to explain everything. It's your responsibility to understand the question by yourself and bring the answer by yourself. Try to bring the answer. You can take 3 to 4 minutes. Don't think that you are not able to solve this question. You don't get the answer. Don't feed the negativity to your brain. நீங்க அந்த மாதிரி பண்ணீங்கன்னா ஆல்ரெடி அதுக்கு தெரிஞ்சிருக்க பேசிக்ஸும் அதை அப்ளை பண்ணாது. அதுவும் ஸ்ட்ரிக்டா அப்சர்வ் பண்ணிக்க. ஓகே எனக்கு ஆன்சர் தெரியலன்னு விட்டுரும். ஓகே, ஸோ இட் இஸ் நாட் குட். டோன்ட் ப்ராக்டிஸ் லைக் தட். ட்ரை டு பிரிங் தி ஆன்சர் பை தி பேசிக்ஸ் தட் யூ நோ. கீ கொடுத்துருக்காங்க கொஸ்டின்ல கிளியரா. கொஸ்டினை தெளிவாக ரீட் பண்ணிட்டு ஆன்சர் கொடு. சொல்யூஷனை எங்கேயும் பார்க்காதீங்க, யாரையும் ஃபாலோ பண்ணாதீங்க. ஐம் ரிப்பீட்டிங் அகைன் அண்ட் அகைன். இட் வில் ஸ்பாயில் யுவர் ப்ரிப்ரேஷன். யாரோ ஒருத்தர் இதை காப்பி அடிச்சீங்க அப்படின்னா ஹவு கேன் யூ பிகம் தி மாஸ்டர்? What is the answer? Try to bring the answer. Anyone got the answer? Drop it in the comment section if you got the answer. No one? First question புரிஞ்சுதா? Chalo. Let me try to solve this question. Listen, guys. See, basically, let us understand the question properly. Already, first of all, there are three terminals, supply terminal R, Y, B. If you observe, already in the diagram itself, this RYB terminal initially connected with a delta, unbalanced delta. It is already clearly given, and each and every terminals is clearly given. What they told, this delta connection is having one side we are having 100 ohm resistor, another side we are having plus J50 ohm inductor, in another side we are having minus J50 ohm capacitor. If you observe it carefully, see what is the impedance across R to B, RBY only sequence, right? Let us see whether it is balanced or unbalanced load. Already question itself they told. Let me prove it. If I am measuring the impedance between R to B, if you observe, I am having J50 ohm. So this can be written as 50 at an angle of 90 degree. If I am observing the impedance between B and Y, where is B? This is B, this is Y. I am getting minus J50 ohm, or it can be written as 50 at an angle of minus 90 degree. If I am observing B to R, sorry, YR, it is giving 100 ohm. It can be written as 100 at an angle of 0 degree. See, if you observe these three branches, whether they are having same value or different values. No, sir, all are different. So I can say the impedance is at RB and the impedance is at BY and the impedance is at YR are not equal to each other. This is called unbalanced load. This is called unbalanced load. First conclusion. You have to understand this. So, question number first என்ன சொல்லிருக்காங்க அப்படின்னா initially this RYB is connected with this unbalanced load set. Okay, sir. Next, again this same a set of 3 RX. 3 resistor means are going to be connected in star. How will you connect them? For an example, let me take a star connected resistor. It will be like this. They only told, I haven't told anything here. I'm just applying the given data. 3 resistor REX. So first let us make the R connection. A set of 3 RX connected in star across RYB. Same R B Y. Okay, they are taking the sequence RYB. Okay, you can interchange. I'm going with the RYB. You know how to do that, right? RBY. I'm going up with the RBY. You can follow the same sequence. Let me change here to avoid the confusion. YB means what? First you have to take R, then you have to take Y, then you have to take B. That's all. Okay, let us come back. Its conclusion is RBY. Let us go ahead with this. இப்போ என்ன பண்ணிருக்காங்க? This RYB sequence is connected with the 3 external resistor. They are in star connection. Star connection is connected with the same RYB. Terminals connect பண்ணியாச்சு. அப்படி connect பண்ணும்போது என்ன ஆகுது அப்படின்னா it is consuming the power as the unbalanced delta connection. Same as it is consuming the same power. Mark this word. Same power as the unbalanced delta connection shown. Now, if you observe this unbalanced, it was clearly given that how many people are there here. One inductor is there, one capacitor is there, one resistor is there. Now, if you observe this, who will be observing real power? See, you have to understand one thing. Sir, அவங்க ரியல் பவரை பத்தி பேசுறாங்களா இல்ல ரியாக்டிவ் பவரை பத்தி பேசுறாங்களா அப்படிங்கிற டவுட் இங்க வரலாம். இல்ல அப்பரண்ட் பவரை பத்தி பேசுறாங்களா அப்படின்றத. Whether they are talking about the real power or reactive power or apparent power, tell me. நான் என்ன சொல்றேன் அப்படின்னா I am talking about, they are talking about real power அப்படின்னு நான் சொல்றேன். How? Because they told in the second case they are connecting resistor and they are telling that the power consumed by this total circuit, real power, resistor will be consuming only real power, na? So the power consumed by this circuit will be equal to the power consumed by this unbalanced load அப்படின்னு அவங்க தான் சொல்லி இருக்காங்க. That is the key. So power consumed by the resistor is only real power. So if it is equal to the power consumed by the unbalanced load, means in this unbalanced load where we have a resistor, only one branch is having resistor. So calculate the real power consumed by this resistor in the unbalanced load. That power will become equal to the power consumed by this total resistor star connected load when they are connected with the same RYB terminal. That is same RYB terminal means across the same line voltage. Okay, sir. Now let us estimate the power consumed by this unbalanced load. See, let me drop it here. If you observe the 100 ohm resistor, it is in delta connection. Then we are having one inductor. Then we are having a capacitor. 1 minute. I'm trying to complete this circuit. Okay, what they have did? They have connected 400 voltage source here. See, this is AC circuit. Polarity you can take in any way. There is nothing wrong here. So this resistor they told this is 100 ohm. Now tell me how will you calculate the power consumed by the resistor in case of delta connection? Only one resistor is there, so total power will become total power will be equal to total real power supplied by the source will be equal to power consumed by this 100 ohm resistor strictly. So how will you calculate that? Power consumed by the 100 ohm resistor can be written as phase voltage, that is voltage drop across the 100 ohm resistor square times divided by resistor value. Though it is a 3-phase load, I cannot multiply by a factor of 3. Why? Because we are having only one phase which is having resistor. it will be equal to, we know phase voltage and line voltage both are equal in case of delta connection, so it will be VL square by R. What is the value of line voltage here? 400. 400 square divided by resistor value is 100 ohm. So 400 square will become 16,000 upon 100 ohm. So 20 will be cancelling out. So the total power consumed by, total real power consumed by the unbalanced load is 1600 watts. Let us focus on the second one, star connected load. You only have to tell me now, how do I calculate the total power consumed by the star connected load? Now they told that there is one star connected load that is also connected with the same 400 voltage source, but this is line voltage. This voltage will be common for all line to line. And here they told that this resistor value is REX, external resistor, right? REX. So when we are connecting the star connection across the 400 voltage, this will be consuming the same power. But here if you observe, in previous case, in case of unbalanced load, only one branch was keeping real power, was consuming real power, was having a real branch. But in this case, all are having same value and equal to each other, that is balanced load. How will you calculate the total power consumption? Let us do that. In order to know the total power, I need to know the 3 times of power consumed by per phase. Yes or no? First calculate the power consumed by per phase. Then we will estimate the total power. How do I do that? For that, I need to know the per phase voltage drop. How will you calculate? Given it is line voltage. In case of star connection, phase voltage will be equal to line voltage divided by root 3. I am considering only magnitude. We know. So I can write this one as 3 times of per phase power can be written as per phase voltage square divided by per phase impedance. Can I write like this? So this can be written as 3 into 400 upon square root of 3, that is the per phase voltage, whole power 2 divided by per phase impedance is REX. So this can be further written as 3 into 400 square will be 16,000 as usual divided by root 3 whole square will become 3 into REX. Both are in the denominator. This 3 and this both are in the denominator only. Na? So this can be 3 getting cancelled out. Once again 16,000 upon REX will be the total power consumed by the star connection. But in the question they told that both powers are same only. Both are same. So power consumed by the unbalanced delta connected load, power consumed by the balanced star connected load, both are equal. அப்படின்னு அவங்க தான் சொல்லியிருக்காங்க, நான் சொல்லல. So power consumed by the unbalanced load is 1600 will be equal to power consumed by the balanced load is 16,000 upon REX. So from here the final answer can be written as the resistor value will become 16,000 upon 1600. Two zeros are getting cancelled, 16 getting cancelled. So finally the value of REX became 100 ohm. See how beautiful this question it is, right? So that is how we are estimating the value of the resistor. Rajesh, 300 ohm. Maybe some small calculation mistakes. Check pannunga. It is 100 ohm. I am getting 100 ohm. See, it's really very beautiful question. And of course, but it is very important in case of three-phase circuits. If you observe, calculations are very simple, and within a minute you can bring the answer. It is also important to keep your attention. Understanding the question also very important. Otherwise, you will be in trouble. Okay. So always try to understand the question properly, what they are trying to say. After that, what they are asking. So we will be requested to what என்ன கேக்குறாங்களோ அதை clear find பண்ணணும். That is very important. Okay. Fine, sir. Now I am giving a small task to you all. Find out the reactive power consumed by the inductor and reactive power consumed by the capacitor. You know, see, voltage is given. You can easily identify the voltage drop across the other phases. But it is very easy to calculate the reactive power also. I don't think that's a big deal for you all. Okay, you can easily figure out. Anyway, from my end, I will do the favor. See what it was given. Given it is 400 line voltage simply. This can be further elaborately written as the sequence is, suppose if it is given as RBY. How will you write the expression line to line voltage? First, we will be writing R to B. I am having 400 at an angle of 0 degree. Then how will you write R to B, then RBY, B to Y. This can be written as 400 at an angle of minus 120 degree. Write everything in a proper way. Then only you will be coming up with the correct answer. So it will be 400 at an angle of plus 120 degree. But here the beauty is, in case of star connection, both phase and line, sorry, in case of delta connection, both the line and phase voltage are same. So directly I can write this will be equal to R Y B. Here the line voltage and the phase voltage all are same. There will be no difference between line and phases in case of delta connection. Okay, sir. So now you know the individual phase voltage drop and line voltage anything. Now how will you calculate the current flow through the individual phases? So let us take. Suppose if I want to know the current flow through this one, I am calling it as R, B, Y. Okay. How will you do? If you want to know the current flow through the R to B, R to B. R to B is what? This is the voltage drop. So I would like to know the current flow through the R to B phase. So this is phase. In delta connection, one more thing what you have to observe is R to B is a phase. See there I am going from this point to this point. In between these two points we are having a phase line. So this current is called phase current. Okay, then which one is called a line current? Line current is that is coming from phase R, coming from phase B, coming from phase Y. It is opposite to star connection. Like in star connection, if you are writing IR, IY, IB, that is called phase current. But in delta connection, that is called a line current. Okay, both are not same. அப்போ எழுதும்போது கரெக்டா எழுதுங்க. எக்ஸாம்லயும் இது மாதிரி தான் எழுதியிருப்பாங்க. நீங்க அதை பார்த்த உடனே லைன் கரண்ட் கொடுத்துருக்காங்களா, ஃபேஸ் கரண்ட் கொடுத்துருக்காங்களான்னு போட்டு குழப்பிட்டு இருக்காதீங்க. Because see in delta this is called a line, this is called a line, this is called a line. Phase current அப்படின்னா one point to another point. So அப்ப என்ன பண்ணுவாங்கன்னா usually phase current can be written as RB, BY, YR அந்த மாதிரி எழுதிட்டு இருப்பாங்க. So don't get confused with that. Okay, it's not a big deal but it is very important. Now it is J50. You know the voltage drop across it. How much it is? It is 400 at an angle of 0 degree. You know the voltage, you know the reactive power. It is very easy to calculate the current. Once you calculate the current, or you can directly calculate the reactive power. Reactive power can be written as V square by X, or you can write I square into X. So you know the value of voltage, so you can write V square. I am just substituting the magnitude. I know it is inductor. So it will be 1600, sorry 16,000 upon 50. 10 will be cancelling out. If I will cancel it, it will become 32. Am I right? I hope I am correct. 160 by 5, it is 32. So it will be 3200 volt ampere reactive power. That is the reactive power consumed by the inductor. Similarly, you can find out the reactive power consumed by the capacitor also. So question la enna ketalum adha clear identify panna theriyum ungalku. It is very important, very important. Okay, fine sir. Now let us go ahead with the next question. So here I'm going to drop a beautiful question and I need your attention for this. You can spend your time after some time try to bring the answer. See the given it is a balanced delta connected load. Just write down a balanced delta connected load. A balanced delta connected load is given as 8 plus J6 ohm per phase. They told it is given only for per phase. Next, under this phase is connected to a this balanced load is connected to a supply voltage is connected to a 400 volt 50 hertz frequency 3-phase supply. If the input power factor is to be improved to 0.9, if the input power factor. If the input power factor improved to 0.9, if the input power factor is improved to 0.9 by connecting a bank of star connected capacitor, by connecting a bank of star connected capacitor, by connecting a bank of star connected capacitor. Then star connected capacitors kodutachu. Then the required kVA R of the bank. Then the required kVAR, that is kilovolt ampere reactive power of the bank. Bank na yaru, the star connected load bank is dash அப்படின்னு கேக்குறாங்க. Now read the question one more time by yourself, because it is not my responsibility. You are only going to write the exam, right? First to collect the data, understand it by yourself. Okay, spend some time to understand the question properly, then try to bring the answer by yourself. Okay. Okay, this is all for this lecture. My sincere suggestion is a three-phase circuit is, you know the importance of three-phase circuit. If you want to get very good score in the upcoming like exams, so it is very important to solve all the questions in a proper way. It doesn't matter how many years or how many hours you are studying per day. You can study 24 hours, you can study 16 hours, 18 hours, it doesn't matter, or you can study only for 3 hours. The matter is all about how effectively you are preparing, how deeply you are understanding the fundamental basics. You don't need to study too much of things here. It is not required actually. But it is very important to understand the fundamental basics. Otherwise, you'll be in trouble. Okay, so try to solve as many questions as possible from your